So there are lots of hyperparameters. There are lots of hyperparameters, right? There are lots of hyperparameters for any multi-layer perceptron, right? Let's list down some of them, if not all of them. The first thing that I have here is how many layers, number of layers. The second thing is number of activation units, number of activation units in each layer, number of activation units in each layer, right? The third one is what type of activation should you use? Should you use ReLU or should you use sigmoid? Right? That's also a hyperparameter. We know ReLU works well, but it's also a hyperparameter that we should be careful about. If you're using dropout, we have dropout rate, right? We have dropout rate. All these are just a few of the hyperparameters that you have in a multi-layer perceptron, right? Now the big question here is how do you do hyperparameter tuning for a MLP? Well, we'll show you a simple example. Remember, our scikit-learn has two very good algorithms. One is your grid search cross-validate. You have your grid search, right? And you have your random search. You have your random search already implemented in scikit-learn. So can we somehow use our Keras models and connect them with all the good things that we have in scikit-learn, right? For hyperparameter tuning, right? Because grid search and random search are useful for hyperparameter tuning. And we have seen lots of examples of hyperparameter tuning for logistic regression, for random forests, and we've seen all of these algorithms in scikit-learn in the classical machine learning algorithms when we learned things like logistic regression. But Keras is a completely different toolkit, right? Scikit-learn is a completely different toolkit. Is there a way for both of them to talk to each other so that I can build an MLP? I can build my models or deep learning models. I can build my deep learning models in Keras or define and have my models in Keras, but use some of the hyperparameter search algorithms that are there in scikit-learn. Okay, so there is a very nice way through which Keras and sklearn can talk to each other. So let's look at an example here, right? In Keras, again, here I've defined a function called best underscore hyperparameters. And here what we're doing here, in this case, in this example that we're showing, we are only tuning one hyperparameter, which is the activation unit type, right? We are calling it the activation unit type called active. Okay, we are not hyperparameter tuning everything. Ideally, we should be hyperparameter tuning everything, but as a tutorial, for you to learn how to do hyperparameter tuning, we're just showing a simple example of ReLU with sigmoid, right? Very, very simple. So I define a function called best hyperparameter with a parameter active. And I'll say my activation here is the active here, right? Except that my model is very simple. It's a sequential model, 784 to 512, 512 to 128, 128 to softmax. This activation function can either be softmax, right? Or it can be ReLU. There are two softmaxes, there are two activation units that will do a hyperparameter or a grid search on. These are two possibilities, so we'll search both of them. And how do I compile my model? My model is simply, the loss is categorical cross entropy, and let's look at what my optimizer is. My optimizer is Adam, one of the best optimizers out there, right? Now comes the fun part. Okay, so I'm saying that there are two activation types, sigmoid and ReLU here. There's a very nice tutorial at this link that we have used for explaining you how Keras and scikit-learn can work with each other for hyperparameter tuning. Okay, so in Keras, there's a very nice thing. In keras.wrappers.scikit-learn, okay, so there is a way to connect Keras and scikit-learn using this wrapper. Okay, so what a wrapper does is, if you have a Keras model, it writes a wrapper on top of it to make it understandable to scikit-learn. Okay, because scikit-learn has some internal format in which it stores models, it executes models, etc. So Keras has created a layer on top of it, like a wrapper on top of it, to make, even though internally it's a Keras model, scikit-learn can still talk to this model and work with this model, right? So from this, we are importing a classifier called the Keras classifier, right? And of course, this is the grid search. Now, when I define my model, these are the most important lines here. I define my model as a Keras classifier, but where is my model defined? My model is defined as my model build function is defined in the best underscore hyperparameters, which is nothing but this function. right? So best underscore hyperparameters is a function where I'm defining my model. I've compiled it. I've not yet executed this model. I'm only compiling the model. So all of my model is ready for execution. And I've created a Keras classifier, right, with the best hyperparameters function, which now defines the whole my MLP model, my MLP Keras model. It even compiled it. It didn't run it. That's it. Okay. Now here I can define some more parameters like how many epochs I want, what is the batch size I want, whether I want a verbose output or not. And I'm saying that my parameter grid, the parameters that I want to try are for my hyperparameter search are sigmoid and ReLU. Right? Now I will just use, this is my standard scikit-learn structure. I'll say grid search cross-validate. What is my estimator? My estimator is this model which I've defined here. This model internally contains a Keras MLP model, right? And what is my parameter grid that I want to search? My parameter grid here, which contains both sigmoid and ReLU. Now, when I say grid.fit, I'm calling this grid search cross-validate as grid. When I say grid.fit, what happens now? What happens now is my scikit-learn, this is how it will work. My scikit-learn, okay, will first take the first value, which is sigmoid. Okay, now it calls this Keras classifier, right? And it says, I want to try it with a sigmoid activation unit. It will get some result. Next, it will try with ReLU, which is what your grid search is. Grid search basically looks at all the values, right? One after the other. And at the end of it, this is simple printing code. What it literally says is the best model that I have is using activation of ReLU, where I'm getting 97.56% accuracy. And when I run it with sigmoid, I get 97.46. When I run with ReLU, I get 97.56, slightly more accuracy, except that everything stays the same. So it's a very, very simple example of how you can do hyperparameter tuning in Keras using stuff that we have already learned in Keras. Okay. So here, what are we doing here? We are leveraging whatever exists in scikit-learn. So in scikit-learn, we already have hyperparameter tuning. We already have hyperparameter tuning in scikit-learn. We are leveraging the modeling, the ease of modeling, especially deep learning models in Keras. And Keras internally is using TensorFlow, right? So there's a very nice structure here. Keras and scikit-learn can talk to each other because of this wrapper code. There is one more caveat, one more small detail that I want to show you. If you are using a CPU, right? If you're using a CPU, you should actually have number of jobs equals to -1, because your scikit-learn can parallelize from a multi-core perspective. This basically says that if your processor has 4 cores, it will parallelize it. But if you're using a GPU, just ignore the number of jobs parameter. If you're using a CPU, keep this parameter. If you're using GPU, avoid it, because in our own experiments, we have noticed that having this when we have GPU slows down the performance dramatically. But if you're just using CPU, if you don't have a GPU, go ahead, use this. If you have a GPU, just ignore this whole thing. Just leave it. Don't even bother about it, the way we have shown here. Okay, so very, very simple way of doing hyperparameter tuning with scikit-learn. There are other tools also. There's a very nice tool called Hyperopt. And there's a variation of Hyperopt called Hyperas. Okay, these are other hyperparameter tuning. These are hyperparameter tuning toolboxes, which can work with both Keras and TensorFlow natively. So in some research papers, in some code snippets, instead of people using scikit-learn, they may also use other toolboxes like Hyperopt and Hyperas. Hyperas is built on top of Hyperopt. These libraries, they have Python interfaces and all of that. They mostly do a very good job of, they're fine design. They're designed very, very beautifully just for hyperparameter tuning. They don't do anything else except hyperparameter tuning. And Keras can be made to work with Hyperopt and Hyperas. Similarly, TensorFlow can be made to work with Hyperopt and Hyperas both. But the reason we have chosen scikit-learn in this tutorial is because we already know scikit-learn. Why bother about learning something new? Of course, there are some advantages of Hyperopt and Hyperas which scikit-learn doesn't have, because there are other forms of, instead of grid search and random search, Hyperopt has more advanced hyper-optimization systems and algorithms called black box optimizations, etc. But for all practical reasons, this is good enough for us. In one of our case studies, we'll show how to use hyperopt and hyperas. Okay, so that you learn more tools. But for now, scikit-learn hyperparameter tuning is good enough for most practical purposes in Keras.